So we got John Gingrich, advisor to TransKarbon, who is currently in Accra, Ghana, in our joint efforts to have a gold trading business there. So he's diligently been pursuing that for the better part of a year here. So brave soul. I just wanted to take a moment here to kind of introduce you. So John's a professional geophysicist. He's got 35 years in the mining and related technology sector, 15 years at Noranda Falconbridge, which is now part of Glencore, where he was the chief geophysicist and director of research and technical innovation. And then John left Noranda to found Geotechnical Business Solutions, a company dedicated to development and finance of exploration opportunities and related technology. So this is kind of where John and I kind of found each other, the intersectionality of technical skills, finance, and on-ground experience. John, how many countries have you worked in around the world?
I've visited 80. I probably worked in about 50 of them.
Yeah. So this is just another gig for you in Accra. It's one of a long line of on-site efforts.
Yeah.
So yeah, originally you did physics at SFU. Is that?
Yeah. I was started off in physics. I actually went in and worked in cyclotron at UBC for a while, and when uranium took off, it became a good fit. I had a physics, I had geology, so I became a geophysicist, and I've been sort of in the mining sector ever since. But because of this background in high tech, I've been sort of had parallel paths my whole career. I always tell people I was the corporate geek. So every time there was a technology program, I was put on the committee. And that always kept me abreast of what went on in the world, not just in mining technologies, but as you know, any technology, whether it's a mobile vehicle, all the GPS, all the other communication devices, everything that goes into it opens you up to a broader part of the world. And that's kind of where we've come together here in TransKarbon. I was looking at actually carbon capture technologies, CO2, and carbon sequestration. Was involved in things in agriculture, which is a key part into this program. So I was looking at soil remediation technologies and more called site-specific solutions to agriculture, as opposed to buy this bag of fertilizer and spread it. So these are common crossovers that Ward and I have, and in particular, the TransKarbon was a sort of, we see it as a marriage of two. He had the core piece of the containment transportation, and I'm working on a more effective way of carbon CO2 capture and other types of gases. So it's a good fit, and of course the idea of putting small standalone, taking what would be deemed as non-productive assets and turning them into very important assets within local communities. So again, we share common visions from a social perspective as well as an economic one.
I think that the theme of decentralization and distributed energy and that delivers the community independence and thus resilience. And I think that that's the large part, the missing piece globally, is the ability to or the initiative to build small scale solutions. Corporates tend to build large scale solutions, but community needs small scale. They're much more affordable, and they solve local problems. So it's been great to be working.
And one of the things, especially when you look at being able to generate power locally, infrastructure costs. Anybody who's been in the power transmission business, the idea of building bigger and better and just put power lines in doesn't make sense. you can have a very high power line going right over a community, but it's going to cost just 300 million to put a substation in to download that power to feed a community of 10,000. It's not economically viable. So you end up seeing around the world poor communities that don't have access to power, and yet overhead there's high voltage power lines moving it to the city 100 miles away. And the same thing with pipelines. We have massive pipelines that moving past communities, and there's no way that they can take advantage and offtake from those systems. So local is becoming far more important, because we just can't afford bigger and bigger infrastructure to pump this stuff, and the costs of then pulling off that stuff is so prohibitive. It does nothing for the communities along the way.
Yeah, oftentimes, as you say, these big infrastructure projects pass by the small communities just out of reach, and they can't get them. So I think one of the things that you could have spoke of it earlier with TransKarbon's modality is to capture, store, and transport. So we function as a virtual pipeline solution for captured gas, specifically methane, but also CO2 and some other gases. So this is the element to be able to capture and distribute at a modest scale, in a modest circumference around the source. And there's so much pipe gas that's around to be downloaded, and as well there's huge reserves of biogas from crop waste to sewage and landfill waste, and flare gas, of course. So billions and billions of cubic feet flared or just wasted every day. So that's the essence, is to take the waste products and redeploy them to the benefit of the most people. And small scale, small is beautiful, as C.F. Schumacher said. So yeah. So tell us a little bit more about perhaps some of the other technological things. I note that you're a mining tech Hall of Famer, and you've been involved in space technology as well. And I think we both share an interest in multiple technologies, whether it be communication, satellite communication. I think we have a shared interest in that, redeploying satellite communication wavelengths for terrestrial use. But you also spend a lot of time up in space, or thinking about space, and up in the air, looking down with some of your megatown system. So take a minute to think of that.
Yeah, I guess haven't been active in a while, but I guess a while ago, I probably was up in the top 5 people in the world in remote sensing imagery. I was hired by the Canadian, German, and Italian governments to help write the business plan for hyperspectral imaging using would have been a 3-country joint satellite operation. So, and the thing for Hall of Fame is Megatem is, again, looking at technologies that can remotely assess the ground without having to do it rapidly, cheaper than, and obviously when there's access issues. So I've been involved heavily in a broad range of technologies for imaging, remote sensing and testing, and maybe not so much you call it remote sensing now, but this got into the area of things that calibrating what you're doing by putting sensors in the ground that then basically feed back detailed information, and continuous, can be on the accessible on the internet, and therefore anytime you do a remote assessment, you can actually calibrate it from information on the ground into very accurate information on whether it's soil conditions, crop conditions, weather, and even then mineral. And for people who are keen on exploration, which is my background, can help you in resource development as well. So there's a broad range of benefits that come from understanding remote sensing.
I think it's a really interesting crossover, certainly with a project that we have in Nigeria with Greg. And I think it's the intersectionality of taking, technologies, sensor technologies, communication, data technologies, such as, I get TEM, and also looking at the ground applications specific to agriculture, which is another essential part of empowering and enabling and making resilient local communities to be able to grow their own food in a much more efficient way without using harmful chemical fertilizers. And I think this is a kind of an excellent example of, again, bringing things from large technology, which you're doing it at the space level or satellite level, and exploration, and then bringing it down to a real world application space where it's small farmers, just being able to manage and monitor the soil conditions through remote sensing. And so we have another team member, Chad Goodwin, who's also deeply into this. He does sensor development and is also contracted by he runs the Carbon Lab for the US Department of Agriculture, looking at ways to improve soil amendments using biochar, and also how to take biomass and use it. Well, he's working with TransKarbon to take crop waste and turn it into high value, high porosity activated carbon that will transport the gases, which is our kind of core technology. So it, as you say, John, it's all about the intersectionality of all these various things. You can't do one thing without knowing about a whole bunch of others. So
well, I think what they call holistic solutions. I think the world of technology now, we tend to think it's power grids and big pieces fitting into a large regional project, where in actual fact it's a whole lot of small pieces on a large regional project to build the framework for a very successful business opportunity. I think the other part to this that's key to our thinking is, if you bring these technologies in, you can enhance crop production by 30, maybe 40%. You can reduce the use of fertilizers that lead to nutrification of the water systems. And we're talking about the taking care of Mother Earth these days. If you can do this at a nominal cost and the farmer's gaining 30-40% production, you're making him wealthy, and then he's going to get access to, whether we're looking at now medicals, remotely delivered education and remotely delivered medicines, or doctors' advices. And you can set up the infrastructure, because once you have a power, then we can put in, instead of high cost cables, we've got some other technologies for making rapid communication in communities without getting into, again, very expensive 5G or and the backbone systems that go with it. We have alternatives, and in the end idea though is we want the farmer to have as good access to technology, to the internet, to real-time information about his fields, what's going on in the world with respect to pricing on his crop. And we don't think that is a pipe dream. We think that's all doable. Just have to rethink the process. It's not a big pyramid anymore. It's a little we've networks linked together, and we're not reinventing the country. We're just basically helping what is really already in place become as efficient as possible.
Yeah, it is. It is very much like emergence theory, where network nodes all connect together and are strengthened by each other. In fact, anybody in the material sciences will tell you that the strongest material is the one that's made up of many little subunits, because they're one massive beam is possible to fail, but a chain link becomes incredibly robust. So I think there's that analogy to be drawn upon. So anyway, well, listen, John, I'm mindful of your late hour there in gun. So I think it's okay if we perhaps wrap up the call, and just want to thank you for taking the time here, and we'll play it back on the at a meeting that we have with the with some folk on the weekend. So I'll loop back to you on how that goes. But
Okay, thanks a lot. And like I said, depending on timing of these meetings, you can always try to, patch me in on a call, but it is a little bit more difficult.
yeah,
But anyway, I wish I was there. We've always face-to-face meetings are better, but in the absence of being there, I guess I'm zoomed in.
you're zoomed in. You're a zoomer, man.
All right.
Okay. Thanks a lot, John. We'll talk to you
All
soon.
right.
Take care.